Hello guys and welcome. I hope that you're well. My name is I play 4K, AK I play 8K, AK I play 16K or UHD King. During this video, I'm going to show you Counter-Strike Source running in 8K resolution native in windowed mode with the help of single Titan RTX video card during GB architecture by Nvidia with 24 GB of video RAM, GDR6 by Samsung, and Intel Core i9 9900K overclock at 5.3 GHz with only 6 cores, 2 cores disabled in the BIOS, and without the hyper-threading technology. So 6 physical cores, 6 physical threads with the aggressive DDR4 3300 MHz CL11 in 3300 MHz. So pretty much achieved was using the Corsair DDR4 5000 MHz CL18, unstable on any motherboard at that frequency except the AMD MSI Ryzen 5000 series motherboard, godlike series. I have a doubt about it, but because it's using the microchips, I clock at CL11. In the end of this video, we're going to talk about the specifications, but anyways, as you can see, this was test done without the recording in real time. By the way, I'm recording this video today in real time with Nvidia ShadowPlay software that is utilizing a little bit of the GPU. So pretty much the FPS will be about 40 FPS difference, and you're gonna see it. I already tested a couple times just to find out for myself, for my curiosity. And keep in mind, guys, that I'm also going to record 16K video resolution benchmark using the 8K resolution native plus the Nvidia DSR. So it's going to render in 16K native resolution and then downscaling the signal to 8K resolution that you don't want to miss. It's going to be available over the UHDking.com or over the 15360 by 8640.com. Go ahead and check it out. Anyway, 660 FPS, amazing result without the recording, and this is at the maximum possible visuals. Let me real quick and show it to you. So 8K resolution, 7680 times 4320, and the model details, texture details, shader details, everything maxed out. Today I'm using the Counter-Strike Source version 3.4, the first version that was released to the consumer in 2004. The same Source game engine that was powering the Half-Life 2 PC game and was used in this Counter-Strike Source PC game as well. So everything will be maximum possible visuals. Anti-aliasing will be 8 times MSAA. Anisotropic filtering will be 16 times. So maximum possible visuals. So DirectX 9 at maximum possible visuals. I believe that it was using the C version, if I'm not mistaken, with the shaders version 3.0 hardware for the video cards and GPU that is capable to support back in 2004 when Half-Life 2 was introduced. DirectX 9C was used in Half-Life 1, Episode 1 and Episode 2 for sure. This is what I remember. So Radeon 9000 series was required to be able to run those games. Anyways, 8K resolution is such a small experience because the developers during that time didn't envision that people will be able to run very high resolutions. Okay, they were kind of limiting into the small black box. Right now, when we're running the Counter-Strike Global Offensive PC game, the user interface is scaled up even in 16K resolution, which is a great guys achievement. And by the way, the Counter-Strike and Source a game engine and Source 2 game engine by Valve is an example how properly develop a game engines, guys, and how properly to develop a games for PC consoles or even the mobile devices. Okay, so this video is not going to be as fast as possible, as again during this video I'm going to share a lot of experience as the graphics designer, 3D artist and 3D animator, a PC hardware enthusiast, system engineer, PC overclocker, a gamer, and yeah, a lot of things will be shared. Alright, let's go ahead and get going. Game developer, software developer as well. So video stress test, guys, this option is available in Counter-Strike Source version 3.4. So same task that I ran at 660 FPS, but right now with the Nvidia ShadowPlay recording at the same time, as you can see, the game engine looks beautiful. I really like this texture right here, the kind of stone with the glass. As you can see, the demonstration of the material rendered with the source game engine. That chrome, unbelievable, guys. That copper homage was unbelievable material, kind of like a ray tracing in real time back in 2004 was achieved already. Look at this shader material of the water, unbelievable, and it was achievable already in 2004, guys. Pretty much, guys, you can achieve anything what you can see today with any game engine that is available on the market, because all of those game engines are capable to render and do all those type of effects. Keep that in mind. So it doesn't matter what kind of game engine you're using, but you want to make sure that the game engine is capable to do that type of effects, that is advanced, like the game engine, any game engine that is capable in 2020, 2022, capable of doing all of this. But Source game engine was the AAA game engine during that time, and it was any game engine such as ID software game engine, tech engine, ID tech engine, and the Source game engine that was that type of powerful, guys, during like early 2000 all the way till like 2007, before the Call of Duty was released, also based on some ID tech game engine sources and etc. Anyways, let me go ahead and use the zoom tool. I'm going to zoom in 632. So I was right, about 40 FPS in particular game was killed by the Nvidia ShadowPlay. Not that much, but during the test, as you saw, we didn't utilize the GPU completely, above 94%. Even if you can see in the menu, it's 1000 FPS, but somehow it's limited. It could be limited by the game engine, it could be limited by the driver, or as again, it could be limited by the game engine by the multiple issues throughout the game engine, and it's not utilizing the Turing GPU architecture completely. So pretty much it's not going to utilize the Ampere GPU architecture or newer GPU architecture by Nvidia or by AMD video cards or by Intel video cards in the future as well. So something is limiting, and we gotta find out, or it could be even limited by the Windows operating system, but I think it's maybe the game engine or the driver. But as again, I use the FPS lower underscore max, and I switch it to 0. Let me real quick go ahead and demonstrate it to you guys, the command, and I did the space and I did 0 and /enter before I did the benchmark. This is a crucial, so it's going to unlock the FPS. So pretty much we're not going to be limited as a user to the FPS. At least if we're going to be limited by the FPS, it's going to be by the game engine. But for those who doesn't believe me that presets such as minimum preset will show you the same FPS, let me real quick go ahead and demonstrate it to you. So 8K resolution, and we're going to go ahead and do everything at the lowest possible preset now. And just because this video is the one of the first Counter-Strike Source PC game videos, gameplays in 8K resolution, I decided why not go ahead and show it to you. It's again 8K resolution native experience over here going on. Smash it. So everything, guys, at lowest possible preset, 8K resolution. I'm going to reboot the game actually for this type of reasons. Okay. And on the background, this is my system. I cannot wait when I'm going to install the secondary Titan RTX and SLI through the NVLink and test it for you guys. Will be available over the UHDking.com YouTube channel that you don't want to miss. UHDking.com YouTube channel. Go ahead and check it out. Or 15360 times 8640.com for 16K video resolution gameplays by UHD King. Everything what is related to 16K UHD. Anyways, as you can see, I'm using the zoom tool as again option just to verify that our preset is as the minimum, but should be at the minimum, and we're gonna benchmark it like that. Okay, let's go ahead and do it. 8K resolution minimum preset. And before benchmark it, I gotta use the command FPS lower underscore max. It's going to be limited to 300 FPS if you're not gonna do it. So if you're receiving like cannot go above 300 FPS even on the new video cards, you gotta use this command right here, FPS max space 0. So FPS lower underscore max space 0, enter. Okay, Alright, let's go ahead and have a look. Close that and video stress test. And load it up again at the lowest possible preset, but FPS will be the same, and as again you're gonna see that GPU utilization will be at 94%, so it's kind of locked at that utilization. As again, maybe the game engine cannot stress more than 94% of the Turing GPU architecture, and just because the Ampere GPU architecture will do more instruction per cycle, IPC per GPU, and will push more data for same megahertz, maybe it's going to be even lower percentage, should be lower percentage on an Ampere GPU architecture such as RTX 3000 series video cards, because the Titan RTX video card is the first generation of the RTX technology by the Nvidia guys, and RTX 3000 series is the second generation, and that generation has advantages. It's pretty much almost 2 times faster than the first generation of the RTX. In terms, it has more CUDA cores, almost by 2 times. No matter what kind of video cards we're talking, it has almost double of everything, and it's performing double performance. Keep that in mind. So RTX 3090 video card will be at least 1.7 times faster, but could be 1.9 times faster. We're going to find out. But RTX 3090 Ti video card will be, or RTX 3090 Ti video card, but I'm saying RTX 3090 Ti video card will be 2 times faster than right now Titan RTX. It's at least should be like that, but we're going to find out. And RTX 4000 series flagship such as RTX 4090 video card will be 3.5 times faster than this Titan RTX. So imagine to that FPS times 3.5. So the FPS will be unbelievable. But as again, maybe we're going to be limited by the game engine, but we are not going to be limited by the game engine when we are talking 16K resolution. So do not miss that 16K video gameplay in Counter-Strike Source. If you Counter-Strike Source fan, or send it to your friends that are Counter-Strike Source fans, they're going to love this video, guys. The best gift that you can give them. So 668 FPS, same deal, minimum preset. So nothing happened, guys, and as you can see, we're limited by something. We're going to find out. However, in 16K resolution, we're going to utilize our GPU higher to 97-99%, pretty much average experience utilization of the Turing GPU architecture in 16K resolution in the games since 2000-2016 that I tested, and normal experience. So there is a possibility if Counter-Strike Source, as again, supports SLI to the NVLink or supports SLI, so I will be able to run 2 RTX 2080 Ti video cards or 2 Titan RTXs and SLI video cards. The FPS will be doubled here, guys. But as again, we're going to find out what's going on, if it's limited by the game engine, if it's limited by the Nvidia driver, just to make sure that we're receiving enough FPS, and decided, you know what, I'm going to go ahead and do it. But it's certainly not limited by me. Let me show you my Nvidia driver. So for those gurus, Counter-Strike Source gurus, as again, maximum FPS low underscore max space 0 command was used, and as again, also I used the maximum performance under the Nvidia driver for this particular test, and as you can see, no DSR was used, so native 8K resolution. And this is how I used for the regular performance on the texture. So maximum possible FPS should be share cache size unlimited, prefer maximum performance, and program settings under the Half-Life 2 source, as you can see, also was saying under the maximum performance and performance, so it should show us maximum FPS. Okay, so from the user point of view, without going to the source code itself, to the source code of the source game engine, this is, guys, was the maximum possible experience on the Turing GPU architecture and Intel Core i9-9900K that was performing almost as 12,900K in PC games. Let me show it to you and demonstrate it to you actually about how fast it was. CPU-Z. First, let's talk about the CPU-Z. So I was using only 6 cores, 6 threads, without the hyper-threading technology, as you saw during the video at the left top corner. But anyways, we're going to look at the single thread performance, because we're talking PC gaming, we're looking at this number. We're talking as a workstation, we're looking at the multi-thread performance. For the multi-thread performance, I have the workstation with the 72 logical processors, which is dual Xeon E5 2699 V3 workstation, but it's Mozilla workstation version 2. But right now it's kind of down because I use this search 8989 Russian guru on Xeon's E5, and I screw up my motherboard. So look like his deal is working on single cores but doesn't work well on a dual core, on the dual socket motherboard, Chinese motherboard X99 or C612. So I gotta revive that motherboard using the BIOS tool now because it's brick now. So it's loaded up and rebooting itself in the cycle after 2 seconds. Okay, but anyways, for the workstation I had that system. I'm looking to build a prototyping right now in faster system as workstation 2 Xeon E5 2699 V3 will dominate the CPU. However, this CPU will dominate anything except the 12,000 series Intel CPUs in PC gaming, and the single thread performance, this is the key. So let me go ahead and demonstrate it to you. 3950X almost by 100 points, above 100 points actually, 108 points, single thread performance, unbelievable performance. 7980 Extreme Edition Intel CPU, 120 points at least. Wow, dominating everything. 10,900K by 40 points. What else? 3700X by 120 points. 9900KF, the same CPU by 100 points almost, the same CPU, but that CPU is using 8 physical cores and 16 threads, total output 16 logical processor, while I'm using 6 physical cores and 6 logical processors, which is fast enough in any PC games in 8K resolution and above, and 16K resolution for sure. This is what I'm using, pretty much 8K and 16K resolution testing over the UHDking.com. I'm focused on a lot of videos like that and content like that, and this is how I'm using. And the higher resolution, the less core you need, guys. This is the formula that you're gonna see in the future PC games. Okay, and as again, PC gaming will be dead in 2025, and you're watching right now the premium of the PC gaming in 2022. And I was showing to you guys since 2016. The first time I saw the 8K resolution was 2012 with the 4 Radeon R9 290 in Crossfire, and the first time I saw the 16K resolution was in 2015 with the 4 Titan X Maxwell GPU architecture by Nvidia in SLI. Okay, for those naysayers, so I have a lot of experience to share. Anyways, this is our performance. Explained everything for every single beginner that's watching this video, what is going on screen. 6 cores, 6 threads, as you can see going on right here. It was running 5300 megahertz. So why I disabled 2 cores? Because I boost up 47% of my overclocking to the stock performance by Intel and boost up the FPS. I added about at least 15% of the FPS boost, or at least 10% of the FPS boost versus the original FPS. Keep that in mind, by the Intel, and achieve it at 5300 megahertz external frequency per each core, and it's switching to 5200 megahertz, which is 5.2 gigahertz, as AVX2 instruction frequencies, which is usually for particular CPUs 9000 series. They're like, okay, AVX2 frequencies are running lower than external frequencies, so it's chilling at the AVX2 frequencies, or it's even chilling to save the energy even when you're not utilizing the CPU, even when it's not too hot. Keep that in mind. And in our case, it wasn't too hot because today it was cooled with the Corsair H150i Pro water cooler, 360mm radiator, 120mm 3 fans on it, so it was Gucci on that. Okay, but it was still switching to 5200 megahertz, 5.2 gigahertz per each core, because it's the nature of the 9000 series CPUs. 12,000 series CPU even brought the new innovations and features, and it's going to be complicated in terms of the overclocking, unfortunately, and more complications will be. But more about 12,900K series and 12,000 series CPUs, and the best choice on that type of CPUs will be available over the UHDking.com by UHDking.com itself. Okay, so motherboard, I was using Maximus 11 here. Memory was 1650 megahertz times 2, 3300 megahertz output. CL11, very aggressive timing, 1T command, but CL11 guys. So you cannot set 3600 megahertz CL14 at CL12. It's going to be unstable even at 3200 megahertz for that type of memory, okay? And this is very micro and special memory by Corsair, which is 5000 megahertz, but as again unstable at this motherboard. But in a second about it. I was using the CPU cache frequency per each core 4800 megahertz or 4.8 gigahertz or 48 multiplier, running dual channel, which is 128 bit. Keep that in mind. 32 gigabytes total, 4 sticks in dual channel, 128 bit, because the platform supports Z390 only 128 bit. Okay, it's kind of gaming, not the workstation, but gaming kind of station, set for the fast and quick responses for the instructions. So as you can see, 2500 megahertz times 2, 5000 megahertz. So XMP 5000 megahertz by Corsair, just like I told you. CL18 is again unstable on any motherboards, but except the MSI Godlike Ryzen 5000 series, which is I have a big doubts about it. Anyways, microchip, utilize it because microchips is doesn't like high frequencies. That's why, because Samsung would be stable on Z370, Z390, 5000 series at 4000 without any issues. But Micron has some, compatibility issues. So, but it's like the latency delay as low as possible, and I utilize it as best as I could. Graphics, Titan RTX, of course, base, boost. As you can see, 7000 megahertz, but because GDR6 times 2, 14,000 megahertz output. Okay, and I overclock it by 1000 megahertz additionally under the current, as you can see, times 2, 16,000 megahertz on the GDR6, 384 bits, which is bandwidth will be by stock without the overclock, 679 gigabytes per second. When you overclocking it, 768 gigabytes per second, 100 gigabytes per second boost. The boost or turbo boost, whatever, 100 gigabytes per second for free from the overclock is amazing, guys. And when we're talking RTX 2080 Ti, you're going to be 352 bits, and your bandwidth will be like 620 gigabytes per second. Okay, by 80 gigabytes per second lower than Titan RTX, even the same memory chips. This is limited by Nvidia drivers and it's not hackable, so this is what it is. So I showed you guys everything what you need to see. 5.746 core, unbelievable multiplier ratio in real life performance. Over here, IDA 64 cache and memory benchmark. Latency, guys, for the first time I benched it and it went below 43 nanoseconds. This is the fastest possible scenario communication with the system RAM, which is the memory, to the CPU, guys. Below 43 nanoseconds. And pretty much the bandwidth in terms of the read, write, and copy, which is almost 50 gigabytes per second or 50 megabytes, 50,000 megabytes per second, as you can see, is the fastest possible scenario for the DDR4 in dual channel, guys. Okay, in quad channel, I'm receiving on my two Xeons E5 2699 V3 CPUs 52,000 megabytes on write, copy, and read. However, on average, it's running in quad channel, which is 256 bit, and today I'm running this system RAM as dual channel 128 bit, and that is running quad channel, but it's running 2133 megahertz CL14, and this one is running 3330 megahertz CL11. Unheard of, guys. Okay, so you can see overclocked by 47%, 53 multiplier external frequency, and 52 multiplier AVX2 instruction frequencies, as I already told you, and cache frequency per each core 48 multiplier, which is 4.8 gigahertz or 4800 megahertz right here. And everything is right here, guys. Everything what you need to know. I tested under IDA 64 GPU benchmark. I tested this Titan RTX video card running completely with this overclock, as you can see, versus the CPU, but with only 6 cores, 6 threads. Of course, the value will be increased if I'm going to increase 2 cores, just like it was designed by Intel. But the frequency will be never go above 5.1 gigahertz on overclock. And believe me, in games, you want to have the higher frequency versus the cores. Okay, because this was the gaming benchmark, so I maxed out the CPU. Everything makes sense. 2 Titan RTX will show double value, which is amazing. Check out the UHD King for that. Okay, and what else? This is the MSI Afterburner plus 85 megahertz on the GPU and plus 1000 megahertz on the VRAM, which is the video RAM. which is times 2, from 14,000 megahertz or 14 gigahertz to 16 gigahertz. Unbelievable value. So yeah, guys, I showed you everything what you need to see. Let me real quick show you the GPU Z, an extra bonus for those gurus, PC hardware enthusiasts. Don't forget to smash that like button. A lot of time, money, energy was invested into you guys. Instead of mining Bitcoin, earn about $15 today, I decided to record this video, but to show you one of the first 8K resolution in Counter-Strike Source, and I will be one of the first gentlemen that will record 16K resolution in Counter-Strike Source using the Nvidia DSR method. Go ahead and check it out because it's going to be the same as native experience of 16K resolution render in real time natively. Okay, so this is the values, guys, when it's overclocked. So pixel fill rate 178 gigapixels per second. Textual fill rate will be 534 gigatexels per second. Bandwidth will be 768 gigabytes per second. So let me release the overclock, and you're gonna see the values, and bandwidth will go like 679. So we're gonna lose 100 gigabytes per second, which means that through the overclock we receive 100 gigabytes per second performance and bandwidth on our GDR6, so it can push more data. It means pushing more data for those beginners. Okay, guys, out of our 24,000 megabytes or 24 gigabytes of the video RAM available on the Titan RTX video card. But if I'm going to release the overclock, we're going to lose that value. Check it out. Went to 672 gigabytes per second by 100. Almost 102 gigabytes lost it for free, and 100 gigabytes is faster than our DDR, guys. 2 times faster, because DDR4 is capable on the dual channel to push 50 gigabytes per second, and theoretically this is the maximum value for the DDR4. Okay, you will say 12,900K is using DDR5, but keep in mind 12,900K will never reach below 44 nanoseconds, and today I'm below 43 nanoseconds. This is unheard of communications, and this is the performance today that you watch will be equal hair slower than 12,900K. So for me there is no reason to upgrade, but however I will go ahead and upgrade it to 12,900K CPU because there is multiple values into that CPU. I will explain more about it, guys, over the UHDking.com that you don't want to miss. Multiple values as the gaming station and as the desktop station, so you don't want to miss that. And copycats will try to copy me and do the video before, but my video will be golden. Okay, so yeah, and we lost, guys, pixel fill rate. We were like 178 gigapixels per second. By 10 gigapixels here per second we can render in real time. We lost that value, and the textual fill rate went to 509 gigatexels. Textual fill rate and bandwidth depends on our GDR6 memory or our video RAM on any video card, and pixel fill rate is based on the GPU performance capabilities. Okay, so when GPU overclocked, this value is increased. When VRAM is overclocked, textual fill rate is increased and bandwidth is increased. So everything was explained. As again, on the background, this is my system running today native 8K resolution. This is the picture, as you can see, as I explained it to you earlier, what's up about the system. Right now I'm putting some great videos for you. Don't forget to smash that like button. As again, I play 4K, 8K, I play 8K, 8K, I play 16K, or UHD King, what we view today. And appreciate me, guys. Share it with your friends, share it with the gamers, share it with the fans of Counter-Strike Source. And over the UHD King, I will provide beautiful demos in Counter-Strike Source running in 16K resolution, beautiful demos in Counter-Strike Go or CSGO or global Counter-Strike Global Offensive in 16K resolution that you don't want to miss, because that's going to be a beautiful grand finals. Also, if you're in Quake 2, Quake 3, go ahead and check out the UHD King playlist for that. Beautiful videos over there as well. And check out right now the videos. As again, smash that like button. Have a great 2022. And for those naysayers, this is the world's first Counter-Strike Source video in 8K resolution native. Was recorded in January 31st 2022, but I also recorded in January 31st 2022 world's first 16K resolution for sure. This is one of the world's first, but that one will be world's first 16K resolution through the Nvidia DSR. As again, don't want to miss it. Smash it, check it out. Till the next time, guys.